We are starting with question number 14 from exercise 4A, ITF. So the given condition is tan inverse x plus tan inverse y, tan inverse z is equal to pi by 2. And we need to prove xy plus yz plus zx is equal to 1. So this is the given condition which we have just written. Take any two terms and send the third term on the right hand side. So this is the general formula for tan inverse x plus tan inverse y. No need to check special cases because we don't know the values of x and y. So this is pi by 2 minus tan inverse of z. Therefore, x plus y upon 1 minus xy. Pi by 2 minus theta. Okay. I'll take tan on the other side. This tan inverse, I'll take it on the other side. And I'll make it tan. And this is pi by 2 minus theta. Now, tan pi by 2 minus theta by complementary angles, it is cot theta. Okay. Now, theta, we have taken as tan inverse of z. That's there in the previous slide. Theta is tan inverse of z. Okay. So, x plus y, 1 minus xy is equal to cot inverse 1 upon z. Now, tan inverse is cot inverse z is 1 upon z. Okay. So, here cot and cot inverse will get cancelled. We'll be left with 1 upon z. So, x plus y, 1 minus xy is 1 upon z. So, z into x plus y, 1 into 1 minus xy. So, xz plus yz, 1 minus xy. Shift this xy term on the left hand side. Xy plus yz plus xz equal to 1. This is how it is proved. Okay, let's go to question number 15. Cos inverse x plus sin inverse x by 2 is equal to pi by 6. Okay, now we'll take one term on the right hand side. We'll take a simple term. We'll not take the x by 2 term on the right hand side. So sin inverse x by 2 is equal to pi by 2 minus cos inverse x. So x by 2 is equal to sine of pi by 2 minus, let this be theta. So sine pi by 2 minus theta is cos theta. Okay, just a small correction, sorry. This is pi by 6. So sine pi by 6 minus theta. We'll use the formula of sine A minus B. Okay, so that is sine A cos B minus cos A sine B. So this equal to sine A cos B minus cos A sine B. So this is sine 30 and this is cos 30. Sine 30 is going to be half and cos 30 is going to be root 3 by 2 in the next step. So x by 2 half cos theta minus root 3 by 2 sine theta. So x by 2, take half common or rather take LCM, root 3 sine theta. So 2 will get cancelled. Okay, now theta is equal to cos inverse of x. Theta is equal to cos inverse of x. So that is resubstitute cos of cos inverse of x root 3 sine of cos inverse of x. So x is equal to cos of cos inverse is gone. X minus root 3 sine of this cos inverse is sine inverse root of 1 minus x square. So you have to convert this cos into sine inverse, cos inverse into sine inverse, because outside there is sine. Okay, so this sine and sine inverse will get cancelled. This x and x will get cancelled. So 0 is equal to minus root 3 root 1 minus x square. So root 1 minus x square is equal to 0. So 1 minus x square is equal to 0 square, which is 0. 1 is equal to x square. So x equal to plus 1 or x equal to minus 1. Now put these values in the main question and check whether what to keep and what to discard, I should say. So cos inverse of x plus sine inverse of x by 2. Shall take 1. Cos inverse of 1 is 90. Cos inverse of 1 is 0, sorry. Okay. And sine inverse of half is 30. So this is equal to 30 degree, which is equal to pi by 6 as required in the problem statement. So yes, this is the correct answer. But then we'll also test for minus 1. We'll also test for minus 1. So cos inverse of minus 1 plus sine inverse of minus 1 by 2. So this is pi minus cos inverse 1. Cos inverse of minus x is pi minus cos inverse of x. And sine inverse of minus x is minus sine inverse x. Okay, so pi minus 0 degree minus 30 degree. So this is 150 degree, 180 minus, which is not equal to the right hand side. Right hand side is 30 degree. So discard this. Okay, you can just write that x cannot be minus 1 as it does not satisfy the given question or the given condition in the problem. Okay, so this checks you need to do. Yeah, 16th one, sine inverse of x plus sine inverse of 2x is equal to pi by 3. Take the easier term on the right hand side. Sine inverse of 2x is equal to pi by 3 minus sine inverse of x. See guys, we could have applied sine inverse x plus sine inverse y formula, but then the method will be very long. So only if it is tan inverse of x plus tan inverse of y, sine inverse of x, tan inverse of x minus tan inverse of y, apply the formula. But then sine inverse plus sine inverse minus sine, cos inverse plus cos inverse minus cos. Generally try to avoid if possible. So 2x is equal to sine pi by 3 is 60 minus this is theta. So 2x is equal to sine 60 cos theta minus cos 60 sine theta, complementary angle. 2x is equal to root 3 by 2 cos theta minus half sine theta. Okay, so this is root 3 cos theta minus sine theta by 2. Common denominator. So this 2 will get multiplied to this 2x, to will be 4x. 4x is equal to root 3 cos theta minus sine theta. Now the value of theta will try and understand. Theta is equal to sine inverse of x cos of sine inverse of x minus sine of sine inverse of x. So this sine and sine inverse will get cancelled. This sine inverse I'll write it as cos inverse of root 1 minus x square minus x. So this 4x minus x, so that is going to be 5x on the left hand side because it will add up. Root 3, this also will get cancelled. We'll be left with root of 1 minus x square. Okay. Now squaring both the sides, 25x square is equal to 3, 1 minus x square, which is equal to 3 minus 3x square. So 28x square is equal to 3. Okay. So x square is equal to 23 upon 28. So x is equal to plus minus root 3 by 28. Now we'll analyze this. See, now the main question is sine inverse x plus sine inverse of 2x is equal to pi by 3. Now if x is positive, sine inverse of any positive value is positive in both the cases. So we'll get a positive angle. But then if we put a negative value, minus root 3 by 28, sine inverse of negative value will give you a negative sine inverse. So this is going to be negative, this is going to be negative. And negative will add up to give you a negative angle. But then this ain't a negative angle. Okay, so we are going to discard the negative value and only the positive value stays into picture. X is equal to root 3 upon 28. Yeah, then 17th one, relatively simple. Tan inverse of 2x plus tan inverse of 3x is equal to 5 by 4. Tan inverse of 2x plus 3x, 1 minus 2x into 3x equal to 45. 5 by 4 is 45. So 5x minus upon 1 minus 6x square is equal to tan 45. Tan inverse on the other side, it became tan 45, which is 1. So 5x is equal to 1 minus x square. So x square plus 5x minus 1 is equal to 0. Okay, so we are going to factorize this. X square plus 6x minus x minus 1 is equal to 0. 6x, x plus 1 minus 1, x plus 1 is equal to 0. 6x minus 1, x plus 1 is equal to 0. So x is equal to 1 by 6 or x is equal to minus 1. Now we'll discard the negative value. I'll tell you why. Because tan inverse of any negative value, that is 2 into minus 1 is minus 2, is negative tan inverse. So this value will give you a negative angle. This will also give a negative angle. So negative will add up to give you a negative angle. But then the right hand side is positive. So we'll discard the negative value over here. That is minus 1. Question number 18, a relatively simple problem. Sine inverse 1 by 5 plus cos inverse of x is equal to 1. Sine inverse of 1 by 5 plus cos inverse of x is equal to sine inverse of 1. This sine, take it on the other side. Okay. So sine inverse of 1 by 5 plus cos inverse of x is equal to 90. Sine inverse of 1 is 90, which is 5 by 2. Okay. But I'll compare this with this formula. Sine inverse of x plus cos inverse x of x is equal to pi by 2. Now when addition of both is pi by 2, the value over here should be same. X and x should give you the same value. This is the formula. But then we have arrived at this point where sine inverse of 1 by 5 plus cos inverse of x is equal to pi by 2. Now since the answer is pi by 2, the value should be same. This and this value highlighted in pink, it should be same. So x is equal to 1 by 5. If it is not same, it won't be then pi by 2. But then since it is pi by 2, the value should be same. And that was question number 18. Okay. Question number 20. I guess just a second. Yeah, I will have to start with question number 13, which I missed out. Okay. So tan inverse of half tan to a plus tan inverse of cot a plus tan inverse of cot cube a. So this is equal to tan inverse of tan to a by 2 plus tan inverse of cot A plus cot cube A 1 minus cot raised to 4A. So this is x and this is y. I applied that formula tan inverse of x plus tan inverse of y over here. So this gives me tan inverse of tan 2A by 2 plus tan inverse of, I'll take cot A common in the numerator, and in the denominator what I'm going to do is I'll apply a square minus b square. So that is 1 minus a square minus b square is a plus b, a minus b, or a minus b into a plus b. Okay, so this term got cancelled. Now convert the cot term into tan term. So tan inverse of tan 2a by 2 plus tan inverse of 1 by tan a divided by 1 minus tan square a. Okay, 1 minus 1 upon tan square a, sorry. So tan inverse of tan 2a by 2 plus tan inverse of 1 by tan a divided by tan square a minus 1 upon tan square a. Tan inverse of tan 2a plus tan inverse of 1 upon tan a into tan square a upon tan square a minus 1. So there are some cancellations in the round bracket. I'll show you. This tan a and this tan a is gone. Okay. So we are left with tan inverse of tan 2a upon 2 plus tan inverse of tan a upon tan square a minus 1. Okay. Till here, I guess the things were pretty simple and calculative, but then now we'll have to apply some logic. Outside we are having tan inverse A. So whenever outside we are having tan inverse A, inside preferably we should have something in terms of tan as a single term. Okay. So we'll make the entire round bracket in terms of tan. See how. Okay. Now first step, tan inverse of tan 2A upon 2 plus tan inverse of multiply and divide by 2 multiply and divide by 2. Okay. So purpose you'll understand, don't worry. Now this is 2 tan A. I'll make this 1 minus tan square A. So I'll take the minus sign outside. The terms within the round bracket will get reversed. Tan inverse of tan 2A by 2. Tan inverse of 2 tan A. I'm taking minus sign outside. 1 minus tan square A. Okay. Now this part. 2 tan A upon 1 minus tan square A. Okay. It's the half angle for tan. So that is tan 2A upon minus 2. Okay. Tan inverse of tan 2A upon 2. Now tan inverse of a negative value is negative tan inverse. Tan 2A upon 2. Now if you observe both the terms are same, they will get cancelled out. It will be 0. So we'll proceed with the next problem, that is question number 19. Sine of 1 by 5 cos inverse of x is equal to 1 Okay, so 1 by 5 cos inverse x is equal to sine inverse of 1. So 1 by 5 cos inverse of x is equal to sine inverse of 1 is equal to 90 degree. Okay, because sine 90 is equal to 1. Cos inverse of x is equal to 90 into 5. Cos inverse of x is equal to 450. Okay, just a second. So see, cos inverse of x, let it be y is equal to 450. Now if you remember, if you try to recollect the domain and range table of cos inverse, okay, so the angle y for cos inverse, it is lying between 0 to 180, but then 450 is out of range, so 450 cannot be taken as the principal value. So for this problem there is no solution.